All right, so let's think about what we've done so far. We are looking at how sound gets into the phone. We have discovered that cell phone microphones and speakers actually have a coil of wire. They have a magnet, and then it requires some movement. And if we talk into that microphone, the vibration of our voice vibrates that diaphragm, which vibrates the coil of wire near the magnet, creating electricity through the idea of electromagnetic induction. Today, what we're going to do is we're actually going to investigate more this idea of sound and this idea of what does that sound wave actually look like that vibrates into that. So what we're going to do is we're going to actually use our computer. So this is a good one to do at home or while you're here. I have a computer program we're going to use, and let me take you through how that's going to look. Okay, so if you are at home and you're trying to do this lab, or even if you're at school trying to do this lab, here's how this works. If you have a home computer, that is probably the best because there's a program I'd like you to install. I will show you at the end how to do this without this program, but with the program, it's actually better. It's a free program you can install. It's called Audacity. And if you don't have the program Audacity, you should get it. It's actually really awesome. So Audacity is a sound manipulator. It allows you to edit tracks. And so what you can do here is you can actually do a recording of your voice. So if you kind of click OK and then you start to record, it is actually recording my voice right now. Stop. So we can see the actual waveforms. We can zoom in to actually see the waveforms that are there. If I hit Shift, I can zoom back out. So that's a good example of what you can do with Audacity. If I get rid of this track, one of the things that's really helpful is if you generate your own tone. So if you generate a tone, I'm just going to generate a 440 hertz. It's going to look like this. Now that looks pretty good, but if we zoom in, you can actually see the tone looks like this. This would be like what would happen if you had a tuning fork in front of it. I can play this, and it makes this crazy, you can actually hear the sound. So this is one of the things that you can work with in terms of trying to figure out what those waves look like if it's a low tone or a high tone. You can actually change the frequency, listen to the sound, and see what the frequency and the wavelength have to do with the actual sound. You can also look at the the loudness of the sound and how the loudness of the sound is affected. You can talk really quietly, or you can talk really loud, and you can see how that affects the waveform as well. So the first part of this lab, you're going to be dealing with Audacity. You can play around with generating your own tones, or you can just talk or sing or whatever you want to do into your microphone. If you have a computer, this is probably the best way to go. If you don't have a computer, you can use what's called a virtual oscilloscope. And you'll see I've got one here. It's actually listening to my voice and making the waves as it goes. I can actually talk, and then I can freeze the input so it can see the voice that I have. I can also, instead of that, I can actually just create sine waves. I have sine waves here, and then I can adjust the frequencies, similar to what you did in Audacity. The downside of this one, however, is that you can't actually hear the sound wave. It doesn't actually allow you to play it. So you can adjust the frequency and see what happens to the wavelength and all that kind of stuff that you can handle just like you would do in Audacity. In order to determine how the pitch is related to the wavelength, you're probably going to want to do the live input, and you can talk like really, really low, or you can talk really high, and you can see kind of how it is, as well as the the loudness and what happens there. So good luck, have fun, and work your way through this worksheet. So hopefully you learned a lot of vocabulary about waves. We learned about the frequency of a wave, or how many waves are created every second. We also learned about the wavelength of waves, or how long the waves are looking from two identical points on a wave.
We looked at the idea of a period or an amplitude of a wave. We also looked at the wave speed. And the wave speed is probably the biggest thing to get out of this lesson. The idea that the wavelength times the frequency gives you the speed of the wave. Waves travel through a medium. The medium being the material that the wave moves through. Right now, the material that my voice is moving through is air. My voice can also move through water, and it can also move through steel, all those kinds of things. But it moves different speeds when it goes through those different medias. We're going to see this come up as a very important fact later on in the unit. So, with the reading, with the exploration that you've done with all these waves, we should be able to use these terms from now on pretty fluently as we talk about waves. Next time, we're going to get into more with this idea of period, looking at springs and pendulums and something called simple harmonic motion.